all to the back. Good. I cannot shout so much. Recovering from weird sore throat. So welcome to, I don't know what class is this. We got two classes here. Got advanced physiology class and biometry. Okay. So special lesson this morning. Have you seen rice plant before? It doesn't count today. Any point before today. So you've been eating rice all your life. Fried rice, porridge rice. What kind of rice else is there? So much rice. Mochi, glutinous rice. Yeah. Not only you eating rice, pigeons do too. So it's only by nature inquisitive to know what is the very plant that I'm eating about. What's the story behind it? It's not so much about the awareness campaign that I'm about to give, because for the biometry class, you're going to deal with activities involving collection of data. So in crop science, plant science, agronomy, and so on, when you're talking about data, you're dealing with living things, okay? You're not engineering students. They can have their own objects to worry about. The objects that you need to worry about are actually living things. So all living things, they got habits because they are continuously developing, continuously growing. So whatever that you see this month, you're not going to see similar physics in the coming month because they are dynamically, actively changing. So the example that we're going to use today, even though it is rice, the fact is true for any plant, any crop, okay? And in order for you to do data acquisition in the right manner, you need to understand the physical characteristics of the crop or plant that you are dealing with, okay? Bear in mind, wherever that we are dealing today, it's only physical. If you go deeper, you learn further, you go to the molecular or genomics level, that is also another set of data, okay? For example, the level of gene expression, the concentration of amino acid, protein content, lipid profile, and so on. These things are not physically visible like the rice that we have today, but they too are data, okay? So we'll start small, okay? So I hope everybody got this. You just came, make sure your friend have this note. Got it? Janganlah angkat tangan macam tu je. Kata, aku nak. Pass around. Got it? Okay. Okay, I know this is a busy looking figure because the two students was prepared this. They don't care about you. How your lesson experience going to be. But we'll see the essence of the crop growth cycle, okay? So in plants, I think you know this already. When you talk about growth cycle, meaning that from the seed to seed, again, plants are categorized into the completion of its life cycle. Whether it can happen within 6 months, meaning that from seed to seed again, and then the plant dies off. That is called annual plant. Or maybe biennial. It takes 2 seasons or 2 years to complete the life cycle. The first season vegetative, the second season reproductive. Or perennial, like many orchard fruit trees. Okay? So after they are done with one cycle, the plant do not die off, but rather they have another set of vegetative cycle, then reproduction, and so on. Okay, so rice, what is it? I know biennial, perennial. Biennial? Can I call it biennial? No? Have you learned your botany? Botany lesson. So what rice growth habit is? Annual. So rice start off as seeds. Where's the mouse? So this would be at the bottom, okay? So it starts off as seeds, it germinates, grow into seedlings, and then it progresses to the reproduction until the senescence, then die. Okay? So you can see that for the growth cycle, phases or steps in growth cycle, it is true for any plant growth habit, biennial, perennial, and so on. It starts with vegetative, then it go to what? Whoa! I need to. Is this outline? I hope it's not. Reproductive, and the third actually is senescence. Senescence or plant aging. Okay. So under reproductive, it can be further subcategorized into the stage of germination, where you get your seeds. Okay, you got your seeds. If you want to see rice seeds, here's the rice seeds. Or maybe you can pass around so that people can. You can take one home if you want. We got so loads of that. Yeah, and then this is going to germinate, and then you're going to get your small plant. What structure is this? If you remember from your botany lesson. What? Plumule. Plumule is a Latin word. It means feathers. Now you got your radicle. So plumule is the baby shoot, while radicle is baby root, right? Then you will start to get your rice seedlings. Yeah. Then after some time, this rice will start to produce side shoot. Okay, like in this example here, it starts off as one plant, but after some time, maybe about a month or so, it will start to produce offshoot. This offshoot or side shoot is the very characteristic of many grasses. Remember, okay, rice is from the grass family. What family is that? I'll say, okay. So this offshoot or side shoot is very important because it will determine the yield of the rice. The more side shoots it has, the more rice grains you're going to get. So this side shoot, there is a special name for that. We call it tiller. Yeah. Look at the plant here. This plant actually started off as a single seedling. Then it keeps on growing and growing. It producing all this side shoot here. So this here, this is actually one tiller. So you can only imagine how many tillers are in this. Started off as one seed. And you get this within 4 months. Right? So rice is a very prolific and fast growing plant, which is good because it needs to feed many people. Right. After some time, this rice clump, so you have many side shoot, right? So each of these, we call it hill. The clump. The clump here. We call it a hill. A hill of rice, meaning a clump of rice. Okay? So this is signified with the elongation of the stem. So when this elongate, this signify the entrance to the reproductive stage. You cannot see it. It's actually at the base here. Maybe I can show you. Should be in here. Yeah, it's around this area. So the moment the flower has started to form in the meristem, which is hidden at the base of the rice, the base of the rice will start to elongate, therefore signifying the entrance to the reproductive stage. And then after that, you start to get the emergence of floral stalk. Okay? And then this floral stalk will start to get fertilized, and then you will start to have your spikelet. Okay, remember from your botany lesson, flower arrangement can be do solitary and inflorescence. So rice having this arrangement that is called panicle. The shape of the fluorescence, we call it panicle. Okay, the small rice paddy you see on the panicle, it's called spikelet. Okay, if you zoom in here, spikelet actually looks something like, I don't have it. This thing here. I'll just make it bigger. It looks something like this. Okay, so the top part is called lemma. This is palea, and this is on. I do not know whether the seed that you have got the on or not. That's like a horn to the rice. Usually wild rice type got this kind of horn, because in the wild the on or the horn looking structure here actually help like a helicopter spinning when the rice falling to the ground to drill and then send the rice seed all the way into the ground. Okay, so this will undergo grain filling. Then it will start to enter the senescence. Senescence is also called the ripening. Okay, right. So for your concern, for your experiment, I think you are going to mostly deal with vegetative rice stage, which is this stage here, or maybe only up to this point. Okay, so for vegetative rice, I was hoping for you to have this, but we don't have it. Because I need to show you, if you go to the field, how are you going to distinguish between rice plant and regular weed or grass? There is a way actually. If you look closer at rice, maybe I can get one from here. Yeah. Let me see the one without panicle, because I don't want to waste the panicle. Oh, the panicle is 100% in here. Oh, it's alright, I'll just take this one. Oh, that's what with a disease? We don't want diseased one. Let's see. That looks good? Okay, this looks good. Okay, ignore this, okay? Because in vegetative state, you do not have this. This is reproduction state, okay? Rice leaf has a special characteristic. If you zoom in here, this is actually, I'll just remove this. This is actually a unit of rice leaf. It has two structure. It has the first part of it. This is called the rice leaf sheath. I'll spell it for you. It looks something like this. So the bottom part of it, we call it leaf sheath. Sheath, like the needle sheath that the nurse used to inject stuff into your body. Okay, that needle got the cap, right? That thing is called sheath, the same thing. Then we have the second part of the rice leaf, which is called leaf blade or lamina. L-A-M-I-N-A-R, lamina. So these collectively make up a unit of rice leaf. Okay, so the interesting thing to realize here is that actually rice do not have stem. You know, plant got stem, right? If you go closer, you come closer to the rice here, you can feel that this hardened trunk here, this is the stem. Actually, no, it's just not stem. It is actually a collection of leaf sheath compressed and come together. Many layers of this. Kind of like banana plant, banana tree. You know banana tree? That is called pseudostem. Okay? The trunk of the banana plant is actually the leaf sheath. The concentric circle of leaf sheath come together, giving the illusion of trunk or stem. But actually it's not. It's very juicy. No wood, no lignin in there. Okay? So the same story for the rice as well. The part that you are interested with is actually the second part of it, which is the leaf here. So how do you distinguish between a rice plant and also the weedy grass? You pay attention to the junction here. You see the junction here? Between the leaf sheath and the tiller. So the junction here, this is called the joint. There are two important structures here that distinguish rice from other wheat. Number one, it's got this structure called ligule. Ligule is the Latin, means tongue. Maybe you can see here. Can you see something sticking up here? That's the ligule, right? The second part is surrounding here. Something like that. Usually all rice do not have this, but vegetative rice they have this. So this structure, kind of half circle surrounding the joint, this is called the auricle. Auricle from the word oris. Oris means ear. Your ear. So you got your tongue, you got your ear, like in the picture here. This is the tongue. This is the auricle here. Then it is a rice plant. Otherwise, if you go to the field, similar looking, got panicle and everything, that is not rice. Okay, very easy. So is this true for all rice variety? Yes, it is true for all rice variety. At some point, they will have this structure. Maybe like this one, this is a bit old, you can't really see the auricle. You can feel it, but you can't really see it. But if you go for the younger leaf, this is not younger, this is nesting already. You can't really see the auricle, okay? Right. What kind of data are we talking about here? Is it you're interested with taking the data, right? Right. So, for the rice at the vegetative state, number one, you can take the data. I'll just make a long list here. Vegetative data. Vegetative data. Sometimes people call it agronomic data. Agronomic. Okay. We go from big big to small. Number one, you can go for the height of the plant. How do you measure the height of the rice plant? Like this one. Can you bring this down so that I can show? Cepat, berat pinggang sangat. Okay. Get your ruler. There are two ways to do this, but you stick to one is good enough. Bring the whole heel together. Your plant is not going to have all this panicle, okay? Because you will be dealing with the vegetative, but I just want to give you the idea. Get the highest leaf. So that will be the highest, right? So measure from the ground all the way to the top. That will be your plant height. It's very important to be consistent with the method. If this is the method that you use for the definition of your rice plant height, stick to this for the rest of the experiment. Okay? Because some people, they are dealing with not very droopy looking leaf. They'll just go up to this. They don't even straighten out the leaf. Okay? That is correct as well. However, do not change the way you measure the plant height. Okay? So, second, I'll just write down that. Plant height. Plant height. Number two, what else? Remember, the rice can produce side shoots, the offshoots. Count that, the number of tiller. You started off as 1, but after 4 months, this is what you get. So count how many tiller that you get, one by one. Just count it. Just count it, okay? So when you get it, tiller per heel. So this can be cm, number of tiller per heel. Just a simple count. Okay, then what else? Physically, when you look at the plant, the leaf, what can you take? You can take the length of the leaf sheath. The length of the leaf sheath. Sheath length. cm. Then blade length. Okay. Now, you can have further data just focusing on the blade only now. I'll just tear it off. Just the blade here. Right, this blade here, you can have further measurement, further dimensional measurement. Okay, you can have, this is leaf length. Then if you go this way, you will have leaf width. And if you use a special equipment, it's called a leaf gauge. Leaf gauge. You can get the thickness of the leaf. Okay, this thing here. This you can get from the lab. Leaf thickness. Right. What else can you get from here? What about the color? Does the color tell anything about the plant health? The color of the leaf. Do you want, what color do you want? Why not blue? Why not red? That looks pretty, right? Yeah, I want pink. I want pink leaf. It goes well with my inner heart. Why do you want green? Why? Chlorophyll content. So the color of it. Color, which is chlorophyll content. I don't bring the equipment here, but we have the equipment in the lab. It's called the SPAD meter. SPAD meter. So very easy to use. You just get the equipment, clamp it, and it will give the reading of the total chlorophyll content of this rice leaf. Because when you look at the rice leaf, you can see that even within one hill, there's various shades of green. There's a deep green, there's a yellowish green, that's blotchy green. How many greens? Petronas green, katak pisang green, so much green. So our eyes can minimally discern this greenness. However, you're dealing with statistics, biometry, right? You want number. Okay, when you need number, you need to use equipment, and this equipment will give you the value, right? Okay, let's see how many you got here. So blade, we got 4, we got number 5 here, number 6 here, number 7 here, number 8 here. You got 8 already. What else? What else can you go with this? Think. We are talking about the blade dimensional value of it. Dimensional measurement. Because in your biometry, you need data, okay? And these data are going to be affected somehow if you got treatment. That's why you need it. What else? What? Leaf area? Yes, true. Leaf area. That's right. Leaf area. Number 9. Leaf area. You can go to the lab and use the leaf area machine, or maybe you want to take the image of this and then use some kind of software to quantify the silhouette of this. And then the unit, you will get something like square centimeter or square meter, okay? What else can you get? Actually, I just taught this last year for the botany student. Got paper? You see, rice here, if you look at the surface, you can feel there is a texture. Not your hairy finger, the leaf. When you feel it, can you have some kind of values coming out from the texture? What? Hairiness level. So, more hairy, less hairy. So what's this texture that you're feeling? Is besides hairiness? Rasa, pejam mata, apa kau rasa? Yang kata kau rasa kecewa, tak terima. That leaf. Rasa apa? Rasa kasar, tu jari kau. Is it smooth? No. So what's that? What's that actually? So actually, on the leaf, if you go closer, you can see that the leaf of the rice change color to this. Don't like this thing. Rice, like any other veins, got veins. Okay, so you got the middle vein here, which called mid vein, and then you got the smaller vein here. Okay, the one that you can actually feel is called large vein. Okay, so large vein, there is another level of it. We call the small vein, but small vein you cannot see by eyes. You need to use microscope. So you can go up to large vein number. Number, what number now? 10. Large vein number. How do you get your vein without using any special equipment? Paper, please. Let's go back to standard one. Kosong tak boleh ke? Short on supply. Use the tracing method. Get your leaf. You see, leaf got two surfaces, okay? You got the upper surface that you do not feel the mid vein, and then you got the under surface of it, the underside of it. You, for this large vein detection, use the underside. Upper side we call, there's a word for it. Upper side of the leaf we call adaxial. Underside of the leaf we call abaxial. So for leaf vein count, use abaxial. How do you use it? Take the abaxial side. It's good to use thin paper. Maybe you got 70 gram. Don't use 100 gram. This is the one of the few times expensive item is not helping. That you can use this activity later, okay? You know, I always got my Sydney A. I should have taken that for my SPM. Ta-da! So, can you count the veins now? Berapa? 43? Janganlah kerja yang tu, jangan ni kecil tu. Berapa tu? Yang halal tu, berapa? How many? Berapa? 15 across the leaf. Okay. So we got 15 leaf veins. Large vein. So count. And guess what? Up to this point, you have taken the data purely. You measure, you get data. You measure, you get data. In science, you can have data in the form of derivation. You combine two things to have a new parameter. In the case of large vein here, the one thing you can do, I'll just rub this, okay? Nobody wants to study about aging. Okay, so you have the leaf width, which is this thing, right? 1. And then you have the large vein number, which is the count. How many of that in here? If you bring these two together, you can turn it into the third parameter. You want to know how many large vein per width measurement. Meaning that, for example, let's say that for the large vein here, you got 15, right? And let's say that the width of the leaf is about 2 centimeters. So what do you get? What? 7.5 vein per centimeter. So this is called vein density. Okay, so you have a new one here. I don't like this thing. Bukan aku suruh buang tu. Buang. Number 11. Vein density. Vein per cm. Alright? Okay? And guess what? That's a further thing that you can know. What else? From this, just from here. It's also a derivative. What else can you know from the vein? You see, one of the characteristic of prolific grass crop, high vein number per area, high density of vein, because the moment plants have managed to make food, photosynthesis, the sugar can immediately get transported to the rest of the plant. The plumbing system is just so good. That's why it tells you when you have this high vein number. So, when you have your leaf, you have your vein. Can you see this thing here in between two veins? So that's another data that you can have. It's called intervenal gap, meaning that what is the width between two veins? Because the narrow intervenal gap that you have, the quicker the sugar can be transported to the rest of the plant, right? So if I can make it large here. So this is your large vein 1. This is large vein 2. So in between here, you have all your photosynthetic cells, right? Yeah. So the width in here will determine how fast the sugar exit into the vein. So when you have wider spacing of intervenal gap, your plant just will take longer to have the sugar transported to the sink organ like this, right? So that is all matter. So how do you quantify this intervenal gap? Well, that's very simple. How many gaps do you have for your 15 vein just now? How many? I leave for you to figure that out. Okay, you're a university student. You should be able to do that, right? So number 12 is intervenal gap. Right. Okay. 12. Is that a lot? Yes. Just from the leaf. Just from the leaf. Okay. There is one more actually, but I think we got it in the lab as well. You know the caliper, the vernier caliper? You can actually use the vernier caliper to quantify for the thickness of the leaf sheath. This leaf sheath here, you can use the caliper, measure the thickness of it. Okay? So if you want to include that, then you have number 13. Leaf sheath thickness. cm. Right. Now you're good to go. You got 13 parameter. That's a lot enough. Cukup kan nak tambah lagi? Cukup. Okay. So imagine that you don't really go to the lab or anything. You just use your phone, whatever you have within your at your disposal. You can already come up with these parameters. Okay. So there is no reason why you won't be able to quantify the effects of your treatment to the agronomic traits of your plants. Okay? And these are going to change. If you give extra nitrogen, somebody will get bigger, somebody will get smaller, somebody will look brighter. Not you, the leaf. And so on. Alright? Okay. So I think for the leaf physical characteristic, I think up to that. Question? I shouldn't be talking very long. I got time restriction here. Clear? No question? So can I ask question? Okay. Good? All right. Okay. You can come here if you want to look at the rice plant here. Just be careful. Don't bring this back home because this should be the data for experiment. Alright? Okay. So tadi tu je lah kot. Tiller count heel boleh ganti dalam bentuk meter square. Ya. Ni benda ni. However, heel circumference subject to change within a day due to the plant moisture level. Yep. If you want to take the plant moisture level, I don't have it with me now. You need to get a string.
Just ambil.
Bawah sekali. Yeah. So you get the circumference. So you will have another data, which is called tiller density per hill. Maksudnya per area of circle, how many tiller the plant is capable of producing. Yeah. Because plants need to decide when is less, when is too much. Because for a given circle, let's say that the circle here is about 20 square centimeter. If the plants decide to have less, then it is not efficient, it's not productive. Because it can have more. Because the more tiller you have, the more grain you will get. However, if the plant grow crazy about it, maybe triple the number of tiller within the same circle area, that will cause soil suffocation. The roots are going to experience asphyxia. I don't know how to pronounce it. You know asphyxia? Kind of like a form of suffocation. I'm not English teacher, so I'm allowed to check for the spelling. Asphyxia. I'll spell it for you. So, A S P H Y X I A. How robot say it?
Asphyxia. Asphyxia.
Macam itulah. Okay, so there is a lack of oxygen. So that's why plant cannot go too crazy about the tiller number. Even though the tiller number is our interest, not the plant interest. The plant just want to be happy with the babies on board. Right, okay. So maybe this is useful if you're interested in breeding. Now that you know all these characters, you can start do what we call as phenotyping. Phenotyping, look for varieties that have favorable reading of any of these. Because you know that these readings somehow correlated to the eventual yield. Then you start to do the breeding program. Then that's how you come up with a super variety. Okay? Right. One of the things that I know scientists is highly looking for in terms of leaf is the narrow interveinal gap. Okay? That's something that scientists are looking for because that is the characteristic of corn plant. You know corn? The corn plant? The corn plant, the leaf vein is so dense. Okay? So that's why C4, because that is the requirement of C4. Okay? Close interveinal gap. That's why it takes 120 days for rice to get the yield, but for the corn, it only requires 70 days for the harvest. Right? Okay? That's why corn is super fast. So if you can find the rice leaf with corn physical characteristic, the leaf, I think you have just found a holy grail of it. Okay? Right. So that's the story about it. Alright? Okay. I think I should be sound like a crazy guy right now. Tu je kot. Ada soalan? Any objection? Okay. Right. Tak ada tu je lah kot. Alright. So I think my class will just continue this afternoon. Kau seronok kan gelar aku? Habis cepat. Kan? Tak lama-lama, relax. So if you got a question, tanyalah your lecturer.
Don't forget about these things will be used when you do research. Later on, you will, especially when you work with rice, so you will at least measure all this. Okay, but